Okay, so we just established the definition of the derivative. Okay, so I want to use the definition of the derivative in an application to calculate the derivative of f of x equal to x squared plus 5, which is a parabola shifted up 5 units. So we're a happy parabola. A in front here is 1, so we're positive, smiling, right? Okay. Now, to do this, I start with the definition, okay? I'm looking for the derivative. So I'm going to write it. The derivative of f prime is equal to what? What does it say the definition is? Limit as h goes to 0 of f of x plus h minus f of x over h. So I'm literally going to write the definition. Okay, now I want to apply the definition to that. So limits are staying the same. I write my limit every time. Now, the problem becomes, what is f of x plus h and what is f of x? Well, we are told f of x equals x squared plus 5. So everywhere I see an f of x, I'm going to put an x squared plus 5. And what about f of x plus h? Well, f of x plus h, think about this. Everywhere I see an x, I replace it with x plus h. So I replace that x with x plus h, quantity squared plus 5. Okay? So if you want to think about it like this, sometimes I do this in my college algebra. I had this f of something equals something squared plus 5. That something happens to be x plus h. Okay, that's what that is saying there. It's a difference quotient. Now, f of x plus h is this piece right here minus f of x, which is this piece right here as defined. Now, that's part of the hardest part right there. The next part that's a little challenging is multiplying it out. But when you are not sure how to multiply it out, just write it out. This squared tells me to write it twice. And so I use FOIL here, first, outer, inner, last. And when I multiply that out, I get x squared plus xh plus hx plus h squared. Now, hx and xh, I can combine those to get 2xh, right? And so let's do that. Let's work through this. So I'm going to replace this piece with that. Okay. And then what about what's going on here? Well, the negative distributes to each piece in here, so this becomes negative x squared and then minus 5. Okay, now that I'm down to this point, I'm going to do some algebraic simplification. X squared terms cancel. The 5 and the negative 5 cancel. And so all that I'm left with is 2xh plus h squared in the numerator. So I have that. What do I see? All of these terms have what in common? They all have an h in common. So what can I do? I can factor an h out of the numerator. If I factor an h out of the numerator, I have 2x plus h left inside. Okay? So I have an h and an h. What happens to those h's as the limit as h goes to 0? I'm going to see some cancellation going on. I can cancel those factors because if I take the limit as h goes to 0, then I'm saying, okay, I can potentially exclude the h itself from being 0 by definition of the limit. So that h's cancel, so that h in the denominator cancels with the h's in the numerator here. And so what do we get? Well, if I plug in h for 0 here, all I'm left with is 2x plus 0, which is 2x. Now, that's not a number. That's correct. What am I saying? F prime of x is equal to 2x. Okay? So therefore, the derivative is a function, just like the original function was a function, input an x value, output. This is a function that I input an x value, it outputs a slope, a derivative, okay? So I like to think of my f prime of x as a slope machine, okay? You give me an x value, and I will tell you the slope of the tangent line at that particular x value. And you think about a parabola shifted up 5 units here, depending on what your x value is. If you have an x value of 0, that's going to get you a horizontal slope here. If you have an x value of like 1, if I plug in 1, that gets me a slope here. If I have an x value of like -2, that gets me a slope here, right? So how do I know this? I take x equal to 0, I plug it into this thing right here. I get 2 times 0, which is 0, right? You see that? F prime is 0, gets me 0. If I plug in this 1 here, f prime of 1 gets me 2 times 1, which is 2. So that line here has a slope 2. Now the further out I go this way, so -2, that's going to be a steeper slope. How do I know that? If I plug in -2 in here, I get a -4. So this line over here has a steeper slope. It's a -4 slope. So the way I like to think about my derivative function is it's a machine that spits out slopes if you give it an input to plug in, okay? So the definition is a little bit tricky, but basically it amounts to running through algebra, okay? So that's the hardest part of it, is just running through all of the algebra. And you got to remember the step-by-step. Now, if you're having trouble like with this algebra part right here, this part going from the definition to this first part here, I've got a video in college algebra using the difference quotient. Okay, so you go in and you go into that college algebra and explain step by step, you know, what to do with the function notation. Okay, so give that a look if you're, you know, a little bit fuzzy on this. In the next video, we're going to talk about how to do the slope of the tangent line. So we're going to continue with this example.